Hey everybody, how you doing today? It's awesome being here. Every time we come to this conference, I was talking to my friend Brian, we come to this conference, we leave with so much more knowledge. I just want to reach out to the SuriCata team. It's just such a great thing that you guys do, and really do appreciate it. My name is Champ Clark. I'm the CTO at a company called Quadrant Information Security. We are MSSP based out of Jacksonville, Florida, but some of the other things that we do is we like to build information security tools. And of course, we're a heavy user of SuriCata, have loved it. We switched our platforms back in 2016 after coming to SuriCon in Washington, D.C., and was so convinced, we were like, we got to go back home and just change everything. So we did that. My talk today is going to be about Meer. You might be asking yourself, what is Meer? So Meer is basically a data spooling engine. We wrote it because we had some needs where we were converting how we handled data on the back end, and we weren't finding really the tools that we wanted to use. So what we ended up doing is creating our own spooling system. And when I say spooling system, think of like a really fancy tail-F. It's like following e-files, it's ingesting them, and then it's doing something to that data. Meer also does some data enrichment, so it can add things to the existing e-files as things are going along. And it is also a data router, so it allows you to have route different types of Eve data to different places. You may want alerts to go in one place, but flow logs to go somewhere else, things like that. When we started working on it, we had very simple design. We want to keep it simple, stupid is our motto. We don't want overly complex configuration files. We also wanted it to be very light on CPU and memory as we could, because a lot of times we're running Meer on the same box that we're running SuriCata on, and we want to reserve as much memory and CPU as we can for SuriCata. Typically Meer, if you have several output plugins enabled, it's usually 100 meg. I was playing with the Elasticsearch output, it was like 60 meg. So your results will vary based on the output formats, but it doesn't use a whole lot of resources. This makes it really suitable for things like embedded systems. So if you have a system that's shallow on resources, it gives you the opportunity to still be able to get that data off and put it to where you want to. We also wanted Meer to be as fast as possible. We had used previous spooling technologies that were older, but they would take a while to start up. You'd have to wait 10, 15 minutes for them to get fully ramped up. And when you're debugging something, that waiting is really bad, because you wait 15 minutes just to see that there's a failure or something like that, so that you have to stop the whole process and start over again. So we wanted to start really fast. And as I said, we didn't want it to be very complex. And down at the bottom of each slide is our GitHub page. So if you want to go there and look at how our YAML is formatted, or the source code or whatnot, feel more than welcome to do that. So we use libyaml just like SuriCata does. So a lot of the configuration files, or the configuration file in Meer, it will look very similar. You'll recognize it because it's all YAML based. We split, there's two big sections in the Meer YAML file. One is considered the core. It's basically telling it how to read in the data, stuff like that. And then there's the output section. So again, trying to keep it very simple. So what we have here is basically what the core looks like. So the core has stuff like, host name, interface, some other description stuff. Like for instance, like description, my awesome sensor, that would be added as part of the Eve. It would be added to it. So it enriched that with that information. The Meer log file is where we store errors and warnings. So you can always go back through and find out what's going on. And since we're doing kind of a tail-F kind of system sort of thing, we need to keep track of where we are in the E file. So we have this thing called a Waldo file, which is kind of a holdover from Barnyard, if you guys are familiar with that from the old days. So it's a where's Waldo file. It's where would we left off? And probably one of the most important things is the follow E file. This is the SuriCata E file that you want to follow. This can have multiple different event types in it. It can have one event type in it or whatnot. It'll try to enrich it all the same. So since we're talking about enrichment is actually considered part of the core area still. So I'll just touch through a couple of those. One that we have here, actually in SuriCon 2019, one of our friends, Jeremy Grove, gave a talk about using the SuriCata engine as a fingerprinting engine to detect assets that are in the network. Now, why this is important is because in our environment, we can ask for things like network maps and stuff like that, but you rarely get them. They're rarely up to date, and we need to understand what we're looking at. So a lot of times we want to know what the asset is that it might be being attacked. So just for example, let's say there is an Apache struts attack, but it's an IIS server. Well, my confidence can go down quite a bit if I can determine through fingerprinting that it's probably a IIS server or that it's a Microsoft system as opposed to Linux. So the fingerprinting allows us to add some data into the alert that basically says this is what I've seen from this system. I've seen these type of protocols being used, like MS-SQL and stuff like that, so we can make determinations. That gets handed to our analysts so they can make better decisions later on. It's also, so it's super passive. So we just have the signatures that we've written. So this gets added to the alert type. This is the only type of event that this gets added to, fingerprinting data, is the alert type, if it's available, if we have that in storage. We can also do things like look up on MAC addresses. The only real place I've found this very useful is things like DHCP logs, where you have things like the client MAC. So we use Wireshark has a MAC mapping file basically where you can do OUI lookups, so you can look up MAC addresses. So when if this is enabled and we actually get a DHCP log or DHCP file and it has a client MAC in it, we can do a quick lookup and look what the vendor is. Again, more about like enriching the data so that if that might be useful for the analysts whenever they're looking at it. The URL for this particular file is in the YAML config, the actual Meer YAML config. I didn't put it in here, but you can go there and just pull it down and automate that whole process if you wanted. We also, of course, add in things like DNS information based off of source IP and destination IP. These are PTR records that are looked up, reverse DNS records, that we actually add to the Eve. Now, we do that on all the Eve files. So for instance, if it's an alert log, we add the DNS there, but if we have flow, we can go ahead and add it there too. We can add it into different places. We have a caching system in place because what we don't want to do is overload the DNS servers that we're hitting because we're doing quite a few lookups. We notice in our environment when we're using this, a lot of the entries come directly out of cache because you do that one lookup and then you might have a small burst of alerts, but a lot of the information might be all tied around each other. So you get a pretty high percentage that come out of the cache. So that gives you kind of some of the ideas about how we're trying to add data into the E file as we're basically fancy tail-Fing it. But as I said, now we have to have the place to send this type of data to. So Meer kind of acts as a data router as well. Right now, we have these 6 different outputs. We can write out to SQL databases, files, pipes. There's a thing called external, which I'll go into later, and of course, Redis and Elasticsearch. And whenever I say routing it, we're routing it off of the event type. So basically, you're going to see in some of these screenshots where down at the bottom, it'll say like alert enabled and DNS enabled and whatnot. What it's saying there is send those type of events to this output format. So these are the types of alerts that we get. So as I said, if we're looking for enhancing DNS, we're adding in DNS, that would be added across the board to whatever event type that we have here. So here's SQL. This only works with alerts. We don't try to put flows into SQL. You'd blow up databases if you try to do that. I have a question. Does anybody actually use SQL as their backend anymore? That was kind of what I figured. I'll be honest, this is my least favorite output format. It's kind of a legacy format. It's based off of what the guys did with Barnyard too back in the day. We put it in there because we were using it as a bridge to get to other technologies. I'll be honest, we're probably going to move away from this and deprecate this when we finally get to a Meer 2.0. The code, I just don't, it just doesn't flow well with the type of things that we're already dealing with. And it's the one output that I don't really like that much. So what we'll probably do is keep this in like a 1.0 branch for the tens of people who still use SQL as an alert backend, and have them have an opportunity to migrate off of that. But in 2.0, all this code's coming out. Again, my least favorite. There are simple ones like file. So remember, we're just going through and we're pulling in data, we're doing DNS lookups, OUI lookups, whatever type of enrichment that we want to do. File just means write it out to a new file in the file system. It can be useful for like debugging and stuff like that, or maybe you have something else that you want to pull in that data. One thing I'd like to notice, you'll see where I said like, it says alert enabled, files enabled. I'm going to scrap that. I'm going to use the more SuriCata style where it's like -alert, -flow, stuff like that. I just don't like this design, but I haven't had a chance to update that code yet. So in this particular case, you can route or split up different types of data, basically by running it through Meer and saying, hey, I want alerts and files and flows, or maybe not flows, but in DNS, so you can kind of split it up very easily that way. So it just takes that enriched data, writes it out to a flat file. We also have things like name pipe output. This can be really useful because it's a way to very quickly have Meer relay data to other tools like Sagan. So for instance, what it does is it takes that enriched data and can write it to a name pipe. And then another tool on the other side of that pipe can read that data in and do further enhancements or further enrichment or further analysis on that. We'd probably like to add in some other support for this as well. But as you can see here, you route it. Again, keep it simple, stupid. You enable it. You give it the pipe location. You give it the pipe size. The pipe size is typically fairly small in Linux when you first start it up. So you give it plenty of kernel space for it to write data to, and then you have the other side read it. And it's really fast. We also have external. Now this one gets kind of weird, and I'm always kind of mixed on this. So what external allows you to do is when Meer hits a certain situation, it can call an external program. So for instance, it could call your Python routine or your Perl routine or Bash. It doesn't really matter. So what it does is it says, whenever this event happens, I'm going to hand your program the JSON output by a standard in. So you'll get the enriched JSON in. The problem with this is it's not very fast. It's because there's a lot of overhead to it. So if you have something like flow logs, will overwhelm the system. But for alerts and stuff like that, that's why you'll see it's usually disabled here, where it says flow disabled and it's only alerts. We've had people, including ourselves, who have used it to integrate with custom firewall backends and stuff like that, or generating block lists based off of criteria that the customer wants. So basically writing like a Python routine that'll read in the JSON standard in and do some magic to it, and then can push a block list out to their network fabric. But if we do that even on every single alert, that can be kind of a problem. So we add in a couple of things that help you filter through this and only send the stuff that you want to the external program. In this case, there is a keyword, it's Meer metadata. So any signature that has in the metadata the Meer external flag will be executed. That's good, but now you have to go through it and make a lot of changes to a lot of different rules. So what we also added is things like policy. So the Cisco Talos team, they have policies in there for IPS. So you can say, if you run into this policy for a certain signature, then maybe you want to fire off an external program there. Or you can use the emerging sets signature severity. That's in the metadata within that, which was interesting to hear Eric talking about how people don't normally set this. Is this the flag that they don't mess with? Because, man, that's terrible to hear if that's the case. But the idea here is that you can say, look, if you get an alert and it's set to critical, then run my external program. If you set any of these to none, then it'll fire off on everything. Probably don't want that, by the way. But yeah. So probably one of my favorite ones is actually the Redis output plugin. It works natively just like SuriCata does, so you can offload this to SuriCata. The great thing about spooling this way is that you can keep replaying data through it. So for instance, if you have a spool file, you can move a spool file in place, then run it, and all your data will show up in Redis, or if you want to rerun it or whatnot. So you can keep replaying that kind of data in it. But my point is, it can do subpub pushing to Redis that way. It can also do, lpush. We also added in the ability to do set keys, believe it or not, which you'll see like there's an append ID. Those are can be useful in certain types of situations where you're creating like an alert queue or something like that. That one's been really good. Of course, supports authentication and all that fun stuff. The Elasticsearch one is probably the newest one that we have. It's the only threaded plugin because for performance reasons, when you're dealing with Elasticsearch, it's easier to spit up several different threads and have them all push data into Elasticsearch. And so it's all tunable. You'll see there's a batch size and a number of threads. So that would be like, 100 batches per 10 threads. So they'll push in 100 items at a time. In Elasticsearch environments, you typically have to tune this a lot, where you're saying like, maybe you're increasing your batch size, you're decreasing your batch size, trying to get that peak performance. So a lot of times, these default numbers probably won't be best for your environment. You'll have to figure that out on your own, just by playing with it and baselining the performance of the Elastic backend. You'll notice in the index we have a index pattern in there. We kind of took the idea from syslog and G. So the idea here is if we're analyzing an alert, the index would become suricata_alert with the year, month, day, so that you can just continually have this running. And you can kind of alter that index pattern to whatever that you need, is the idea there, so that you can just do this through variables. Then, of course, down at the very bottom, you have things like the routing stuff. So what to send to Elasticsearch. Again, all these plugins can be independent of each other. You might want to send alerts to Redis. You might want to have other alerts that are going to, or events going to Elasticsearch. So that's kind of the idea there. This does support TLS and authentication with Elastic. So if you were saying, I want to push this across the internet to well, probably wouldn't do that. But if you wanted to push it across somewhere and use TLS, feel free more than to do so. So what we want to do is continue adding in things like enrichment, maybe adding in some open source threat intel, maybe doing MISP lookup integrations, any kind of that kind of stuff I'm kind of open to. So if anybody has any suggestions about what type of data enrichment that they think would be useful, I'd really love to hear it. Even much so, if you don't get a chance to talk with me today, feel free to open a ticket on GitHub saying, I would like to see this type of enrichment happen. I really want it to become more of an enrichment engine. So I'm open to those ideas. Some of the ideas that we're talking about is taking, for instance, like an alert fires off, being able to, and I saw this, I think, with Fever the other day, which I think is a very interesting project, where they were taking the alert information, grabbing that flow ID, and then using the flow ID to correlate all the other events, and then they build this massive JSON blob. I was kind of interested in doing that as well, because then it saves like our analysts from having to dive into each sensor if I can hand them this big blob that has a lot of that information correlated into one particular event. I'll probably get started on that. That one seems like kind of a fun one to get started on, so I've been looking forward to doing that one. So that's one of the things we want to do. Brian brought this one up, our friend over here, thresholding on duplicate signatures. So you basically have a rule, it has no threshold on it, and start blowing up the sock, being able to come up with some guidelines in Meer that basically say, look, based off certain criteria, if you see a rule firing off 100 times, 1,000 times, write it out 100 times to Elastic or Redis or whatever, but then make a new JSON entry that says, hey, this event over here did this, 1,500 more times. You know what I mean? So that you're not clogging up, your consoles and whatnot with all that type of stuff. So then, as I said, future output support. We're going to, as I said, with the 2.0 code, we're getting rid of the SQL stuff. I'd be interested to know what people use on their backends to insert data into, like what type of backends, that you're interested in. One of them that I was really interested in before flying up and listening to Eric's great talk was, and I believe I talked with Jason Ish about this like years ago, was taking the Eve output and then creating PCAP data based off of the Eve output. The idea, what I was hoping, was to get more stream not just the particular event, but more of the stream, and then create it into into a PCAP. But it sounds like Eric's done some great progress on the conditional PCAP support. So in a way, I think he's probably even in a better position to be doing any of that kind of stuff. One output support that we'll probably add, because I could see it across multiple uses, it's just a generic template for doing HTTP post requests to different applications. You remember how earlier I was saying we call this external program, but use 9 times out of 10 what the external program is doing, it calls a Python routine which rips some data apart and then posts it into some other application through an API call or something like that. So maybe to come out with an output format that's a little bit more generic so that you could use it across different types of platforms. This also might be useful into submitting alert data to other types of data into SOAR systems and stuff like that. I'd be interested to know anybody's thought on that as well. And basically, I don't know. I mean, we're pretty much a blank slate on this. We're willing to listen to anything about how to get data from enriched and to different types of backends. So we would like to hear what your thoughts on that. I would like to say real quick, these are the places for Meer and another project that I do called Sagan. So Meer is, of course, what I'm talking about today. The read the doc stuff I'm currently trying to get updated. I'm a little bit behind. Sagan is a log analysis engine. We've actually adopted or followed a lot of what the SuriCata team has done. So Sagan is a log analysis engine. When I say log analysis, it's like syslog, Windows event logs, things like that. But it uses the same rule set structure that SuriCata does. So we adopted things like XBits and stuff like that. So from our standpoint, from our SOC, whenever they're looking at an event, we don't have to double train our guys. They basically understand how both in a log environment, how we're triggering on things, and on a packet environment, how we're triggering on things. So I wanted to point out, if you're interested in log analysis and you're also a SuriCata fan, you may very well like Sagan as well. It creates e-files, just like, so everything that I just talked about the data enrichment and whatnot, also would apply to the Sagan e-files as well, because we write in the exact same format as SuriCata does. So it kind of makes the two tools work kind of fun together. And if you guys would like, I think I left plenty of time for any Q&A. I'm all for it.